Next topic we are going to see is about the spectral lines of hydrogen. So we have various series lines which are based on the hydrogen. These series are Lyman series, Balmer series, Paschen, Brackett and P1 series. So these are the 5 series of spectral lines of hydrogen. So what are they? Lyman, Balmer, Paschen, Brackett and P1. Okay, so all these series are based on this only one formula. It is given by 1 by lambda, which is equal to r into 1 by n square minus 1 by m square, which is equal to nu bar. Here nu bar denotes the wave number and it is also said to be the inverse of wavelength. Okay, so nu bar is equal to the inverse of wavelength, so we are writing as 1 by lambda. Okay, and then r is said to be the Rydberg constant. Okay, r is said to be the Rydberg constant. It is a constant value. It is given by 1.0937 into 10 power 7 m per minus 1. Okay, so this is a constant value for r. It is given by 1.09737 into 10 power 7, and m and n are said to be the positive integers. Okay, so m and n are said to be the positive integers. Nu bar is what? That is the wave number, lambda is the wavelength, and r is a Rydberg constant. Okay, now we will see with this series one by one. First one is the Lyman series. Lyman series, we have to take the value of n is equal to 1 because it is said to be the first series in which the atoms from all the other orbit comes to the first orbit. So consider this to be the nucleus and this to be the first, second and third orbit, such a way. Okay, so how we write with all the series is, so if any electron that is coming from all the other orbits to the first orbit, that comes under the Lyman series. Okay, then next is, if any electron that is coming from any other orbit to the second orbit, that comes under the Balmer series, and any electron which is coming from the outer orbits to the third orbit, that is Paschen series, fourth orbit, that is Brackett series, and the fifth orbit, that is said to be the P1 series. Okay, so for this we are substituting n is equal to 1, and for Balmer n is equal to 2, and this is n is equal to 3, n is equal to 4, and for P1 it is n is equal to 5. Okay, so if n is equal to 1, then the m takes the value of the values other than the 1. Okay, so what are the values other than 1 is 2, 3, 4, etc. Okay, and the wave number, it always lies in the ultraviolet region. Okay, so this Lyman series lies in the ultraviolet region, and the wave number is given by what? Nu bar, which is equal to 1 by lambda into r into 1 by n square. What is the value of n here? It is 1, and so we are writing as 1 square minus 1 by m square. So this is about Lyman series. Next is Balmer series. So n is equal to 2, then m takes the value other than 2, which is 3, 4, 5, and the wave number is given by nu bar is equal to 1 by lambda into 1 by lambda, which is equal to r into 1 by n square. What is the value of n here is 2, and so 2 square minus 1 by m square, and this Balmer series lies in the visible region. Okay, Lyman series lies in the ultraviolet region, Balmer series lies in the visible region. Next is Paschen series. In this Paschen series, it lies in the infrared region. Okay, here n is equal to 3, and so m takes the value of 4, 5, 6, etc., and the value is given by nu bar is equal to 1 by lambda r into 1 by 3 square minus 1 by m square. Clear? So next is what? Next is a Brackett series. Here n is equal to 4 and m takes the other values, which is 5, 6, 7, etc., and so the wave number is given by nu bar, which is equal to 1 by lambda r into 1 by n square. So 4 square minus 1 by m square. This lies in again in the infrared region. Okay, first one is ultraviolet, next is visible, and the next two are infrared, and the last one is n is equal to 5. So m takes the value of 6, 7, 8. Here wave number is given by nu bar is equal to 1 by lambda r into 1 by 5 square 1 by minus 1 by m square. This also lies in the infrared region. So this table gives you a short form of all the series. First one, Lyman series, n is equal to 1, m takes a value of 2, 3, 4. This lies in the ultraviolet. Then Balmer, n is equal to 2, m takes the value of 3, 4, 5, and this lies in the visible region. Next, Paschen, n is equal to 3, m takes the value of 4, 5, 6, and it is in the infrared region. Brackett, n is equal to 4, this is 5, 6, 7, and it is also in the infrared. Then last p-fun series, here n is equal to 5, this is 6, 7, 8, and this also lies in the infrared region. So this is about a short form of the spectral series of the hydrogen atom. Yes, clear? So last we have the limitations of Bohr's atom model. We have very few limitations. They are, first one is the Bohr atom model is valid only for hydrogen atom, and it is not for complex atom. This can hold only for the hydrogen atom. When the spectral series are closely examined, so spectral series ஒன்னொன்னு பார்த்தோம் அப்படின்னா ஒவ்வொரு லைன்லயும் எப்படி இருக்கும்னா வந்து ஃபைன் ஸ்ட்ரக்சரா இருக்குமா, ஒரு ஒரு லைனும் நிறைய லைன்ஸ் மேக் பண்ணிருக்குமா, அதுக்கு பேர் என்னது ஃபைன் ஸ்ட்ரக்சர். அண்ட் இந்த ஃபைன் ஸ்ட்ரக்சர் பத்தி என்ன சொல்லல, Bohr atom model explain பண்ணல. Okay, and the Bohr atom model also fails to explain the intensity. So intensity வந்து explain பண்ணல இந்த Bohr atom model. Next last point is the distribution of electrons. Electron வந்து ஒவ்வொரு ஆர்பிட்லயும் எப்படி டிஸ்ட்ரிபியூட் ஆயிருக்கு அப்படின்றது this model did not explain. Okay, so these are the limitations of Bohr atom model. Yes, clear with this? Thank you.